All right. So yesterday we talked about powers and exponents and what the base was and what the power was, and we solved those problems. Today we are going to be talking about prime factorization. All right. So let's before we do that though, let's review from yesterday. All right. So if I have, let's say I have five squared, right? Two power of two means squared. And then remember the power of three means cubed. Okay. And so this is the just a refresher, this is the base, and this is the exponent. Okay. All right. And so you would say this 5 squared, or 5 to the power of 2. Okay. And then when we do this, it's not 5 plus 5. We're multiplying 5 2 times. Let me erase all this. Okay. All right. And so that would be 5 times 5. 5 times 5 equals 25. Okay. All right. And so what if we have 5 cubed, though? If we have 5 cubed, that's 5 times 5 times 5. So we know that 5 times 5 is 25, and then we have to multiply this 5. So 25 times 5 is 125. Okay. All right. So that's from yesterday. All right. So today we'll talk about prime factorization. All right. And we're going to start off this lesson by talking about things that we talked about last year as far as prime and composite numbers. All right. So let's refresh. A whole number that has exactly two factors, one and itself, is a prime number. All right. So prime number has one and itself as factors. Okay, and so examples of prime numbers would be 7, 3, 5, 2. Okay, because 7 times 1 is the only thing that equals 7. So 7 and 1. And then same with 3. 3 times 1 is the only equation we can do that equals 3. So 1 and itself. Same with 5 and same with 2. Okay. A number greater than 1 with more than 2 factors is called a composite number. Okay. So for instance, they have 9 here. Let me erase this. So 9 has how many factors? Let's see, composite. All right. And let's look at 9. So we have 1 times 9. 1 times 9 equals 9, but so does 3 times 3, okay? And so altogether, 9 has 1, 2, 3 factors. We don't count the 3 2 times, so that's what makes it composite. It has more than 2 factors, okay? All right, so let's do this real quick. It says draw a line matching each number with its list of factors. Circle the prime numbers. All right, so let me just scroll up here real quick. Let's see if I can move up here. There we go. All right, and let's just do this together real quick. You're probably done already, but let me go ahead and start. So I know that 31 will be here. Let's see. 23 is a prime number. Oh, we need to circle the prime. I'm sorry. Circle the prime numbers. All right. What about 100? 100. Well, I'm looking at this, and the biggest number is 100. So I know 100 is a factor of 100 because 1 times 100 is 100. So that goes there. 48. Yep, there's the factor of 48. So that's going to go there. And then this is 50 right here. Okay. So it looks like, I'm sorry, 31 is here, but it's also a prime number. Okay. Try this one. There you go. All right, and so that's what that would be. Okay, and so so that's all vocabulary. We have prime number and composite number. Okay, and then we're going to talk about prime factorization and factor tree. All right, Okay, well, let's keep on moving. Okay, it says identify prime and composite numbers. Whole numbers are either prime or composite. 0 and 1 are neither prime nor composite. Okay. All right, so the first one says state whether each number is prime, composite, or neither. Explain. All right, so we have 35. The factors of 35. We have 1 and 35 already. We know that. But what else can we multiply together to get 35? Well, 5 and 7. Anytime a number ends with 5, then you know that 5 is a factor of that number. All right. Okay. And so since 35 has more than two factors, it is a composite number. Composite. All right. Composite. All right, let's go ahead and look at 17. 17. Factors of 17 are 1 and what? Well, 1 and 17. 17, let's get that out of the way. Yep, so since 17 has exactly two factors, 1 and 17, it is a prime number. Prime. Okay. All right, so you can kind of remember prime is Optimus Prime. There's only one of those. Okay, so you can think of prime that it's just only one in itself. Okay. All right. It says equivalent expressions using prime factorization. Okay, so we're done identifying prime and composite. We're going to move on to prime factorization. Each composite number can be written as a product of prime numbers. I'll say that again. Every composite number can be written as a product of prime numbers. Okay, this is called prime factorization. A factor tree is a diagram that can be used to find the prime factorization of a number. You can generate equivalent expressions using prime factorization. All right, so let's look at example 3. All right, over here to the right, that's the factor tree that they're talking about. It's the diagram that can be used to find the prime factorization of a number. It says write the number being factored at the top. So they did 120 up here. 120 is here. Choose a pair of factors. Okay, well, 6 and 20 are factors of 120. So they chose those two. Continue to factor until only prime numbers remain. Okay, so they factored out 6. So 2 times 3 is 6. And for 20, 4 times 5. All right. Well, 2 and 3 are both prime numbers, but 4 is still a composite. So they had to split up the 4 into 2. So the prime factorization of 120 is 2 times 2 times 2 times 3 times 5. Now you could put it this way. We could do it this way, times 2 times 2 times 5, but we don't have all the numbers in line. See how they're numerically in order? So make sure whenever we do prime factorization that we list them in order numerically. Okay. Okay. We can also write it, instead of writing the 3 2's, we can say 2 to the third times 3 times 5. Okay. We can also do that as well because there's 3 2's, and so we just put those together, because if we multiply 2 times 2, that's 4, and 4 times 2 is 8, right? Okay, and so 2 to the power of 3, or 2 cubed, also equals 8. All right, here we have 36. Write the number being factored at the top. Okay, 36 is there. Choose a pair of factors. So we have 3, and so we're supposed to fill in this factor right here. All right, well, what times 3 equals 36? Well, it's going to be 12. Okay. All right, well, we know 3 is a prime number, so it's going to be automatically on our list. So I'm just going to drop down a 3 there. All right. Now, 12, let's break that. We have 4, so 4 times 3 equals 12. There is 3, we dropped it down. And then what are my prime numbers that multiply together to equal 4? Well, 2 times 2, so 2 and 2. So the prime factorization of 36 is 2 times 2 times 3 times 3, or 2 squared times 3 squared. Let's take a look at this one. This one has a negative number. This is negative 70. All right. And so to factor a negative integer, like negative 70, use negative 1 as a factor. Okay. Since negative 70 equals negative 1 times 70, factor 70 and include negative 1 in the prime factorization. Okay. So here's an example of that. They listed the number at the top. Then they broke 70 out as 7 times 10. 7 is a prime number, so it automatically goes down. 10 can be split up into 2 and 5. So 2, 5, and 7 are prime numbers. So the prime factorization of negative 70 is negative 1 times 2 times 5 times 7. Now let's practice on our own real quick. All right, so we're gonna do the prime factorization of 60. All right, first I have to think of the factors of 60, right? So we have 1 times 60, 6 times 10, 2 times 30, right? Okay, and we could probably go on. But let's go ahead and split out this 60. So, all right, so we could do 2 and 30. We could do 6 and 10. I'm going to do 6 and 10 here. So 6 times 10. Okay, and then both of these are still composite numbers, so we have to break them out until we get to prime numbers. So I'm going to start with the 6. So I know 2 and 3 equals 6. All right, those are both prime numbers. So let's go down here to 10. 5 and 2. 2, 3, 5, and 2, those are all prime numbers. So the prime factorization of 60 equals 2 times 2 times 3 times 5, or we could say 2 squared times 3 times 5. Okay, let's do one more. All right, let's do negative 16. All right, let's see. Let's think of the factors of 16. We have 1, 16, 2, 8. Okay, all right, so let's break this out. Let's do 2 and 8. 2 and 8. Okay, oh, we could also do 4 and 4, right? We could, but let's stick with 2 and 8 because 2 is already a prime number, so I'm just going to drop it down here. And then let's break out 8. 8 is still a composite number, so let's see if we can get to some prime numbers. So we have 4 and 2. Okay, well, this 4 right here, uh, this 4 can be broken out. So 2, 2, and then this is a 2. Okay, all right, so you notice that this is a negative 16 and I don't have a negative number here. All right, so the prime factorization of negative 16 is negative 1 and then 2 to the 4th power.